Howdy, my most excellent petro pals. It's Papa. Hope you guys are having a very nice September. The cool weather makes me want to go out there and collect rocks and see places. Maybe it does you too. Anyhow, today I think I have a special treat for you because we're going to talk about one of the most beautiful places that Grammy and I have loved for many years, Yosemite National Park. We're going to learn about how the park was formed geologically. We're going to look at the rocks of Yosemite National Park. We're going to look at the park itself, how it's laid out, the different elevations there. And we're going to also take a look at how rivers, lakes, and glaciers have had a very big hand in shaping this wonderful place. And along the way, we'll pay tribute to an individual who loved Yosemite, went there as a young man before it was even a national park, wrote articles about it, and really helped to get Yosemite designated as one of our national parks. So stay tuned, and I hope you like this video, so please subscribe. Thank you a million to you wonderful people who have subscribed to my channel. It warms the cockles of me heart. So here we go, Yosemite National Park, geology. Yosemite National Park is located in the Sierra Nevada mountains of California. On this map you can see that it's just about due east of San Francisco. Yosemite is a paradise of 769,000 acres. That's about 1,200 square miles. It receives about 4 million visitors a year, and it is the showcase of the Sierra Nevada mountains. So let's take a closer look. On this park map, you can see the roads are red, and the rectangular section of roads marks the Yosemite Valley itself, which lies at about 4,000 feet above sea level. The valley is not big. It's about 7 miles long and about a mile wide plus or minus. But in that small space, it presents us with fantastic world-class views. Right now, the black arrow is tracing the road that leads from the valley south to the Mariposa Grove of Giant Sequoias, just south of Wawona Campground. Now the black arrow is pointing to the Tioga Road, Highway 120, which runs right across the park on the top of the canyon walls. The top of the canyon walls are about 7,000 or 8,000 feet above sea level, with high peaks all around that get up to 11,000 feet and more. Wintertime brings lots of snow to Yosemite. The valley roads stay open, I believe, but the Tioga Road is closed all winter long. Here comes a Yosemite slideshow for your viewing enjoyment. Outstanding features of the canyon walls of Yosemite all have names, and here are some of them. These canyon walls rise up 3,000 feet from the valley floor. There are 3 main streams that flow into Yosemite Valley. Coming in from the northeast is Tenaya Creek. Coming in from the east is the Merced River, which is the main stream of Yosemite Valley. And then coming in from the southeast is Illilouette Creek. And just for fun, here's Rock Papa taking a soak in Illilouette Creek. Illilouette Creek, just above the Illilouette Falls. And yes, there is a bathing suit. Giant sequoia trees are the biggest trees on the planet, not the tallest. That goes to the redwoods of Northern California. There are several groves of sequoias in Yosemite National Park, but the grandest one is in the southern part of the park, called the Mariposa Grove of Giant Sequoias. And the giantest of giant sequoias, called the Grizzly Giant, is there. It is huge, and it's estimated to be about 2,700 years old. Repeated fires and lightning strikes have only served to give it more and more character and grandeur. Many of you guys know who this is. Yep, John Muir. He came to the Yosemite in the late 1860s and fell in love with it, lived here for many years. He was a very good man whom I have great respect for. He was very instrumental in getting Yosemite designated as a national park. In fact, he is considered to be the father of our national parks, and I can't wait to meet him someday up there in the mountains of the sky. So let's jump into some Yosemite geology. The Yosemite granitic batholith makes up a whopping 95% of all the rocks in the park. These rocks were placed deep underground during the Jurassic period Nevadan orogeny and were later uplifted into mountains as the Basin and Range province began to extend. Calaveras complex rocks make up about 2% of the total. These rocks, which were also in place during the Jurassic Nevadan orogeny, consist of various kinds of lavas, passive margin sediments, and bits and pieces of ocean crust that were shoved up onto the continent. And finally, and very importantly, 3% of the rocks of the park were made by glaciers, and we'll talk a lot more about glaciers a little bit later. The Sierra Nevada batholith is really made of many plutons that are all bunched up together. So let's look at some of the different rock types that make up these plutons. Here's some Yosemite granite. And Yosemite granite is considered to be a very strong, cohesive kind of granite, mainly because it cooled very slowly and developed big crystals, and it has a high proportion of quartz. Here's some more granite, and this is actually the Elberton, Georgia granite. Granites are made of lots of quartz, lots of potassium-rich feldspar, a little bit of sodium-rich feldspar, and a little bit of biotite mica and some muscovite. Yosemite National Park also has granodiorite, and that's a rock that's just between granite and diorite in its rock reaction. That just means that it has a little more sodium-rich feldspar and biotite than normal granite, and perhaps just a wee bit less quartz. This is diorite. Granite is a felsic rock, whereas diorite is an intermediate reaction rock. Diorite has less quartz than granite and maybe little or no potassium-rich feldspar, a lot of sodium-rich feldspar, a lot of biotite, and some hornblende. And here's some dark diorite just to show you that the composition of all these rocks can vary. The dark stuff is probably a lot more hornblende. Calaveras complex rocks are found in scattered places on top of the batholith rocks. These are mostly sedimentary rocks that were superheated and metamorphosed by contact metamorphism with the hot batholith rocks, which turned them into a metamorphic rock called Hornfels. Here are some pictures of this weird rock called Hornfels. Hornfels are very hard and tough rocks that old-time pioneers used as whetstones. And there are mafic rocks here too. This is a piece of what looks like to be diorite that was encased in one of the granite plutons while the pluton was molten, and then after it cooled, the dark rock was incorporated into the pluton. They call this kind of rock a xenolith. Hey rock buds, now let's take a brief look at the Nevada and orogeny, which put in place most of the rocks that we find in Yosemite National Park. During the Nevada orogeny, the Pacific Ocean plate subducted beneath the western edge of the continent. Let's see what happened. The first thing that happened was the ancient Pacific Ocean plate subducted beneath the edge of the continent, creating a continental volcanic arc, underlain by huge granite and diorite plutons, the future core of the Sierra Nevada mountains. The black blob in number 1 shows that passive margin sediments and ocean crust were also shoved up on the edge of the continent. This whole package is called the Calaveras Complex. Next, a series of volcanic island chains approached and crashed into the western edge of the continent, bringing with them more passive margin sediments as well as serpentinite-rich ocean crust. All these crashed volcanic island chains are collectively called the Western Jurassic Terrane. Then about 30 million years ago, the San Andreas Fault developed, with the land on the west side of the fault sliding north relative to the land on the east side of the fault. Then about 17 million years ago, this sliding action of the San Andreas Fault began to stretch the western edge of the continent. As this part of the continent was stretched to nearly double its original size, huge cracks developed in the crust between what is now eastern California and western Utah. The cracks got wider and deeper, developing into block faults. Huge blocks of crust rotated up along these faults, forming mountains with broad, flat valleys in between. In eastern California, the rotation of these blocks brought up all of the granite and diorite plutons of the Sierra Nevada batholith, turning them into the magnificent Sierra Nevada mountain range. That's why the eastern face of the Sierra Nevada range is so steep and abrupt. It is the actual face of the rotated block, while the more gently sloping west face of the Sierra Nevada mountains represents the top of that block. Hey rock buds, after all this rock action, Yosemite National Park was still not finished. We have to look at the work of water and ice. Let's do. When the Sierra Nevada mountains rose up, it created really steep stream gradients. And over millions of years, the streams cut down into the rock, creating steep V-shaped stream beds with rocky bottoms. Then the Ice Age came with massive snowfalls. The snow piled up in low spots high in the mountains, widening these spots out into what geologists call cirques. The snow piled up, eventually turning into ice. Ice as hard as a rock and sharp as a razor. As more and more snow and ice were added, the whole package became a glacier and began to flow down the mountain. Glaciers were like giant bulldozers, pushing up piles of rock and pounding that rock into smaller rocks down to the size of powder. The rocks were incorporated into the body of the glacier as well as pushed up in front and along the sides of the glacier as it moved. The result was long ridges of ground up rock and dirt that followed along the sides of the glacier. These are called lateral moraines. When the glacier finally stopped moving and began to melt, it left another huge pile of rock and dirt at the end of it called a terminal moraine. Glaciers turn V-shaped stream valleys into U-shaped valleys, and that's what happened in Yosemite Valley, but that was not the end. In Yosemite Valley, when the last glacier stopped moving and began to melt, it left a terminal moraine about where El Capitan Rock is, all across the valley. Meltwater from the glacier piled up behind this moraine in Yosemite Valley, creating Lake Yosemite. Over thousands of years, silt piled up on the bottom of the lake, turning the U-shaped glacier valley into a flat-bottomed lake bed valley. Eventually, the lake totally silted in and the moraine may have been broken and all the water drained off, leaving Yosemite Valley the way we find it today. Hey Rock Buds, let's take a closer look at Yosemite glaciers. Here are some glacial features that we're going to have a look at. This is Lake Tenaya, a glacial lake located on the north rim of the canyon along the Tioga Road. The bulldozer action of glaciers dug out this lake as it has dug out many of the lakes in the Sierra Nevada mountains. Eventually, stream deposits filled the lake in with material from moraines, etc., turning the lake into a glacial meadow. And that brings us to Ptolemy Meadows, a magnificent meadow created by the Ptolemy River Glacier and found along the Tioga Road. Ptolemy Meadows is filled with the Tioga Till, which is just all kinds of glacier material like moraines, etc. And it is by far the largest glacial meadow in the park and maybe surrounding areas. In the mid and late 1800s, there were 10 or 15,000 sheep grazing along the Ptolemy Meadows. One of John Muir's most favorite camping sites, here beside an interesting geologic feature called Soda Springs. Dr. Joseph LeConte of the University of California, along with his students, also visited this area, and he wrote a book about it. Grammy and I last visited Yosemite in 2018, and we had a look and a taste of Soda Springs. Volcanic activity associated with basin and range rifting has put iron and carbonation into this cool spring. There's springs water in here, and here's the filter. It tastes irony and it tastes carbonate, just like a Coca-Cola. When the glacier slid across the rocks, it created glacial polish. That's the pinkish patch of rock in this picture. The glacial polish protected the rock until it was eroded away, and then the rock eroded much faster. The way the glacial polish flashed in the sunlight made John Muir call the Sierra Nevada the range of light. Remember the terminal moraine that created Lake Yosemite? Here are some pieces of it that you can find in the valley today. Moraines can be made of rocks of all sizes, from Volkswagen size down to dust. This big old rock is called a glacial erratic. That means the glacier carried it down from the mountains with it, and when the glacier melted, it just set it down right there. There's a theory that says some of the rocks at Stonehenge are glacial erratics brought from very far away by the ice, but I don't think it's true. The last great act in the formation of Yosemite Valley had to do with joints and cracking of the granitic rocks. When a granitic pluton first forms and cools, it's covered by absolutely miles and miles of other material that puts tremendous pressure on the rock. When it's finally exposed by uplift and erosion, it begins to expand just like a cicada busting out of its shell. This is called spheroidal weathering, where onion skin-like layers pop off of the rock in succession. This cracking and jointing looks like a man-made feature, but it's not. It's just part of the natural process of expansion. A big result of all this expansion, cracking, and popping is landslides in Yosemite. These happen regularly but infrequently, with the last major landslide occurring in 2017. They too have played their part in shaping this magnificent valley. Okay, Rock Buds, that's it for Yosemite National Park. Thank you so much for watching. If this was useful to you, please subscribe. And this is your Rock Papa saying happy rock hunting to you fantastic folks. Papa out.